Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Good morning. How are you today? Today we will talking about math induction. So what is math induction? Mathematical induction let as n be any statement about a natural number n. So if 1 as 1 is true and then 2 as k implies as k plus 1, then Sn is true for all natural number n. So we already learned about arithmetic and geometric. So Sn in here there are any statement if arithmetic, geometric, or etc. But you need to find the two of them. The first, you need to prove that statement S1 is true, and then the second, SK implies SK plus 1. Then you can say the Sn is true for all natural number n. So without further ado, so let's jump to the example of mathematical induction. Using the principle of mathematical induction, prove that 1 plus 2 plus 3 plus dot 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 plus n equal n times n plus 2 n plus 1 over 2 with the n element of natural number. Because we're talking about mathematical induction, we already know for mathematical induction they have two steps, everyone. So from here we can let Sn it's equal with 1 plus 2 plus 3 plus dot 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 plus n equal with n times n plus 1 over 2, right? So from here, the step 1, you need to put the n to be 1. Okay? So we have LHS, LHS, and RHS. So when we have left hand side or LHS equal with the RHS right hand side. Okay, so from here, when you want to put the S equal 1, it's not the meaning you want to change the N to be 1. So N equal with the N plus 1 over 2. So change the N to be 1. So 1 equal with 1 plus 1 over 2. So 1 times 2 over 2 cancel. So 1 equal 1 is true. So from here, we can continue for the step 2. The step 2, we are talking about SK. Okay, so all of them, you need to change to be K. So 1, 2, 3, dot, 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 plus K equal with K plus 1 over 2. So this one implies with the S K plus 1. Okay, so when you find the K, you need to change K plus 1. Okay, so 1, 2, 3 plus dot 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 plus dot plus K plus 1. Imagine, before K plus 1, so there is K as always exists. Okay, so in here, you need to substitute K to be K plus 1 times by K plus 1 over 2. Okay, so from here, wait a minute. So from here, we can say, in here, we can say 1 plus until the K, they have the same K plus 1 over 2. Okay, 1 until K plus 1 over 2. No KK, right? This one is K plus 1 over 2 plus K plus 1 equal with K plus 1 equal with K plus 2 over 2. So from here, in here is left hand side. This is right hand side. So depend on you what you like to prove. So I would like to prefer to try to answer with the left hand side. So when you prove the left hand side, the result it should be same with the right hand side. Okay, so prove left hand side. Okay, so I want to make the same denominator by 2. So this one is K square plus K plus 2, K plus 1. And then k square plus k plus 2k plus 1 over 2. So in here k square plus 3k plus 1 with the 2. So we can factorize them, k plus 1, k plus 2 over 2. So the result is the same with the, what happened? K, okay, k plus 2, sorry. Okay, this is 2, sorry everyone, 2, 2. So this is the same result with the right hand side, k plus 2, k plus 1 over 2 everyone. So this one, I can say this question is, we can prove it's true. The proof is true. Okay, so you can write the proof is true. That's it everyone. Using the principle of mathematical induction, prove that 1 plus 3 plus 5 plus dot 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 plus 2n minus 1 equal n square, where an element of natural number with the math in the induction. So we know that Sn equal 1 plus 3 plus 5 plus dot 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 plus 2n minus 1 equal with the n square. So for this first step, we want to change the n to be 1. So left hand side, it should be equal with the right hand side. Left hand side to n minus 1. Right hand side is n squared. So put the n to be 1. So 2 times 1 minus 1. 1 square, 1 equal 1. So from here, this one is true, right? So we want to continue to the SK. So change all the variable n to be k. So 1 plus 3 plus 5 plus dot 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 plus 2k minus 1 equal with the k square. Okay, so this one, it should be implies with the sk plus 1. Okay, so from here we can write 1 plus 3 plus 5 plus dot 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 plus 2k minus 1. This one is still the same, but plus with the k plus 1. So 2 open bracket k plus 1 minus 1, it's equal with the k plus 1 square. So from here, 1 until 2k minus 1, it's the value is k square. So from here, we can sub them with the k square plus, and then you fix this one first. 2k plus 2 minus 1, okay, equal with the k plus 1 square. So it's left hand is the right hand. So we want to prove the left hand side. So prove the left hand side. K squared plus 2k minus 1. So we factorize them. K minus 1. 2k plus minus, oh sorry, this one is plus k plus 1 square. So this one is the same with the right hand side. So this one I can say it's proven. Okay. Principle of mathematical induction prove that 1 over 2, 1 over 6, and then etc. until 1 over n times n plus 1 equal with the n over n plus 1 n element of natural number. So from here, we can write Sn equal 1 over 1 times 2 plus 1 over 2 times 3 plus dot 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 until 1 over n times n plus 1 n over n plus 1. Okay. For the first step, you need to find the S first. Okay, so I just take from the left hand side equal with the right hand side. It should be equal. Okay, so left hand side is 1 over n plus 1 equal with the n over n plus 1. So change the n with the 1. So 1 over 1, so 1 plus 1. 1 over 1 plus 1. So this one, this one is 1. So it's 1 over 2. It's equal with the 1 over 2. So this is true. Okay, so for the number 2, you need to change the n to be k. So it's equal with the 1, 2 over 1 over 2 times 3 plus dot 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 plus 1 over k, k plus 1 equal with the k over k plus 1. So this one, it should be implies with the s k plus 1, it's equal with the 1, 2 plus 1 over 2 plus times 3 plus dot 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 plus this one, it's always be there, 1 over k plus 1 plus 1 per k plus 1 k plus 1 plus 1 equal with the k plus 1 over k plus 1 plus 1. Okay, so from here we can change them with the, or we can substitute them with the k. So k plus 1 plus 1 over k plus 1 k plus 2 equal with k plus 1 over k plus 2. Okay, so from here, in here is left hand side, right hand side. Proof, I want proof left hand side. So from proof the left hand side, we make the same denominator, k plus 1, k plus 2. So this one is k plus k plus 2 plus 1. Okay, and then equal with, it will be equal with the k square plus 2k plus 1 over k plus 1 k plus 2. Okay, because the space is not enough, so let me factorize them. K plus 1, or this one is 2, k plus 1 k plus 1 over k plus 1 k plus 2. We can cancel the both of them, the both of the side. So the result is k plus 1 over k plus 2. So this one is same with the right hand side. So it's proven. Okay, everyone. I hope the exercise you need to work with the 4 of them. 1, 2, 4, and the 7. Just work with the circle. But if you want to do more, it's better, guys. So thank you for today. I hope you understand what I'm explaining. Assalamualaikum warahmatullahi wabarakatuh.